Alright guys, so today we're going to talk about acid-base neutralization reactions. In the last video we talked about how acids and bases behave in water. Water is amphoteric, which means that it can act as both an acid and a base. So if we add acid to water, the water is going to act as our base. If we add a base to water, the water is going to act as our acid. So today we're going to talk about the neutralization reactions that occur when we react a strong acid with a strong base, a strong acid with a weak base, and a weak acid with a strong base. So let's start with the neutralization of a strong acid and a strong base. When we react a strong acid and a strong base, we're going to produce water and what we call a salt. So from a chemistry standpoint, a salt is something very specific. A salt is going to be the ionic compound formed by the neutralization reaction of an acid and a base. And one of the reasons that's so important for a biological chemistry class is because of the drug industry. So organic salts, especially those formed from the reaction of an amine with a strong acid, are going to have much greater water solubility than the amine themselves. So this makes amine salt drugs much easier to administer. Okay, so let's try an example of one of these acid-base neutralization reactions. Let's write a neutralization reaction for hydrochloric acid, which is a strong acid, and sodium hydroxide, which is a strong base. Okay, let's see what you came up with. So we have our strong acid, hydrochloric acid, and we have our strong base, NaOH, and this is going to work like a double replacement reaction. So the two anions are just going to swap places. And HOH is, of course, water, so we can rewrite that as H2O. So when we neutralize hydrochloric acid with sodium hydroxide, we produce water and our salt, sodium chloride. Okay, so let's try an example with a weak acid and a strong base this time. So remember in last lecture we talked about how for this class our weak organic acids are going to be phenols and carboxylic acid. So I want you to go ahead and pause this video and see if you can figure out how we can neutralize this carboxylic acid with sodium hydroxide. And while you're at it, I want you to go ahead and name our organic reactant and our organic product. Okay, so let's see what you came up with. So we started with a 3-carbon carboxylic acid, so that would be propanoic acid. And this reaction is going to work exactly like the previous reaction where we have a strong acid and a strong base. It's going to be a double replacement reaction, and you're just going to swap the anions. So we end up with HOH, or water, and a salt. Okay, so how do we name our salt? So this is an ionic compound, so we're going to name this the same way you learned how to name ionic compounds in the last class. We're going to list the cation name followed by the anion name. So our cation is sodium. So our anion is a carboxylate ion, the conjugate base of our carboxylic acid, and we learned how to name those in the last video. So we take the carboxylic acid name, drop the oic acid, and replace it with OH. So our anion name is propanoate. So when we neutralize propanoic acid with sodium hydroxide, we create a water molecule and our salt, sodium propanoate. Okay, so what if we react a strong acid with a weak base? So this is a synthesis reaction, unlike the last two, which were double replacement reactions. So this is a reaction where we have two smaller compounds combining to form a more complex compound. So in this reaction with a strong acid and a weak base, we're not creating water, we are only creating a salt. So go ahead and pause this video and see if you can come up with names for both our organic reactant and our organic product. Okay, so let's see what you guys came up with. So we have a 2-carbon amine. So the name of this molecule would be ethanamine. And when we neutralize ethanamine with hydrochloric acid, our hydrochloric acid is going to act as the acid, of course, and donate a proton to our base ethanamine. That's going to give us a positively charged azanium ion and a negatively charged chlorine ion, and those are going to come together to form our salt. We're going to name the salt just like we do any other salt. We're going to list the cation name followed by the anion name. So our cation name is going to be the name of our azanium ion, and a 2-carbon azanium ion is going to be ethyl azanium. So do you remember back in the last class in chapter 3 when you learned how to name monoatomic anions? So we're going to name a monoatomic anion by taking the element name and changing the ending to "ide," I-D-E. So our anion name would be chloride. So the final name for the salt would be ethyl azanium chloride. Okay, so we've covered neutralization reactions using a strong acid and a strong base, a strong acid and a weak base, and a weak acid and a strong base. So that only leaves one combination left, our weak acid and our weak base, but we're going to save that for next time when we learn how to synthesize amides.